autonomous disaster recovery option. Though cost is low, but recovery time objective is high. Hence, this is not preferred for mission critical production application. This method of DR is preferred for non-production or less critical application databases deployed in autonomous database. In OCI console, for the disaster recovery menu option, you will see the DR type column will have the value as backup based and the state column will have the value as standby for this type of disaster recovery. Note that the term standby here doesn't mean the standby database. The PRL value would be a backup copy, which in case of autonomous data guard will have a value standby, since it creates a standby copy of the primary autonomous database in case of autonomous data guard. Note that during switchover or the failover operation, the peer autonomous database will be instantiated from the backup of your primary autonomous database that is available in the region. Just like autonomous data guard, you can create a local peer backup copy or a cross-region peer backup copy, or you can have both the local and cross-region backup copy. You can also combine both disaster recovery options. That is, you can have a local peer backup copy and a cross-region autonomous data guard standby database, or vice versa. But at any point, you can have just one local peer and one remote peer. Backup-based DR is supported for all workload types. That is, autonomous data warehouse, autonomous transaction processing, autonomous JSON database, or Oracle Apex for application development. Let's now understand how does it decide where the instantiation of the autonomous database should happen in a backup-based DR to ensure resiliency. In case of local peer, if your autonomous database is deployed in a multi-AD region, then the instantiation of the peer autonomous database should happen in another availability domain than the one in which your primary autonomous database is provisioned. However, if the region is single AD, then the instantiation of the peer autonomous database should happen in another fault domain than the one in which your primary autonomous database is provisioned. In case of cross region, the peer database will be provisioned in availability domain of the remote region, which could be single AD or multi AD region. Now we will look into the individual peer types. First of the kind is local peer backup copy. Backup based DR is enabled by default with one local peer backup copy, always created for the existing or non-autonomous database. It cannot be disabled. This uses backup copy of the autonomous database that is stored locally in the same region as your autonomous database to be used for instantiation. As per the usual business continuity plan, you can perform switchover operation to validate the local DR setup. A switchover operation will cause the peer copy to take the role of primary and the primary database to become the backup copy. Note that the switchover operation is initiated from the primary autonomous database details page. There is no details page for the local peer backup copy. You can use it for testing your database failover for certification or audit reasons, or for testing your application's failover procedure when there is a database failover. Note that the switchover will succeed only if no data loss can be guaranteed. Unlike autonomous data guard, there is no automatic failover capability available with backup-based DR, irrespective of whether it's a local or cross-region peer. After a switchover or failover operation, there is no change to the database connection string or the URL of the database tools associated with your autonomous database. You do not need to download the wallet and reconfigure your application once the peer database takes the primary role. All the autonomous database features that were available with primary will remain available in the peer copy once it is instantiated and takes the primary database role. Adding a peer database does not bring down your primary database. There is no loss of connection, and your application continue to perform read-write operation while the peer backup copy is being configured. This is typical of when a cross-region peer backup copy is being configured in the remote region, which involves copying of the database backup and redo to remote region. You can also update a backup-based DR type to one autonomous data type. Cross-region peer backup copy. Like the local peer backup copy, you must also validate your cross-region peer backup copy by performing a switchover. Unlike the local peer, there is no cross-region peer backup copy by default. In case of cross-region peer backup copy, your autonomous database backups are automatically copied into the remote region, which is a paired region of the OCI region that you had chosen for deployment of your primary autonomous database. You must have subscribed to the paired region before you add a cross-region peer backup copy. These backups should be used for instantiating the peer database in the remote region during a switchover or failover operation. In contrast to local peer backup copy, switchover operation in case of cross-region peer backup copy is always performed from the details page of the cross-region peer backup copy. This is similar to autonomous data guard. When you click on the cross-region peer backup name, it will open up another tab of the OCI console for your cross-region peer backup copy, from which you can click on the switchover link. Failover operation to cross-region peer backup copy is manual, so you first initiate the switchover from the cross-region peer backup copy details page. If that doesn't succeed, then it will update the page and provide a link to failover. When you click on the failover link, it will instantiate the cross-region peer backup copy and assign it with primary role for your autonomous database. Switchover or failover operation to cross-region peer backup copy will cause the database connection string and the database tools URL to change. Hence, you must effect those changes to be able to connect to the cross-region peer backup copy, which will become the new primary. You have to download the wallet from the details page of cross-region peer. Once it becomes available with the primary role, use that wallet to configure your application for re-establishing connection with the database. There is an additional advantage of having a cross-region peer backup copy. You can convert the cross-region peer backup copy to a snapshot standby and open it in read-write mode for evaluating some of your application changes. This you can use it for up to 2 days and then revert it back to the earlier state. Now let's take a quick glance into the RPO and RTO during manual failover to backup-based DR, similar to what we have seen in autonomous data guard. In case of either the local peer backup copy or the cross-region peer backup copy, during manual failover, the RTO is 1 hour plus 1 hour for every 5 TB, and the RPO is 1 minute. That is, you'll lose maximum of 1 minute of data. Thus, in this lesson, we learned about the backup-based disaster recovery feature provided in autonomous database that can automate switchover and failover in the event of a disaster to its corresponding peer. As mentioned earlier, since it has higher RTO, it is recommended to use this kind of disaster recovery configuration for non-critical application databases deployed on autonomous database. Hope this helped you to understand the backup-based disaster recovery and some of the key features of the two peer types. Thanks for watching. Hello everyone. In this demo, let's check the disaster recovery feature of an Oracle Autonomous Database. Before we get into the disaster recovery feature, we'll first create an autonomous database. I'm in US East Ashburn region, so let's first create autonomous database. So click on the hamburger icon and from the drop down, select Oracle Database. And here, we will create an autonomous transaction processing database. So this is one of the instances which was created previously. Now let's create a new autonomous transaction processing database here. Click on create autonomous database and make sure you have chosen the required compartment. This is one of my compartment which I'm using for this demo. Let's change the display name. I'll keep it ATP demo. Same name I'll give for the database name. The workload type is transaction processing because we are going to create a transaction processing autonomous database. And the database version which is currently available is 19C for an autonomous database. We'll choose one OCPU. We do not want to enable auto scaling, so we can disable this. And for storage, we can let it be just 1 TB and leave the storage auto scaling box unchecked. Provide your credentials for admin user. And for network access, we'll have it in a public subnet so that it can be accessed from anywhere. And when you choose secure access from everywhere, this will be checked by default. You cannot uncheck it. And for the license type, choose the license which is applicable. In this case, I'll choose DYOL. And for the database edition, I'll put it as enterprise edition. So rest of the things you can leave it. If you want to check on the advanced option for setting some of the additional configuration stuff, click on show advanced option, and here you get to configure the encryption key. You can skip rest of the tabs for this demo. Click on create autonomous database. Let's give it a few minutes to complete the provisioning of the autonomous transaction processing database. So our ATP database has been provisioned. If you check the role of the database, it is primary. You can scroll down to check the details about the database. Like this is the general information. This is regarding infrastructure, because we are using a shared infrastructure, dedicated infrastructure has a value, no. And under the disaster recovery section, you see the role is primary, and we have a switchover link which is active. This is because by default, when you create autonomous database, by default it creates a local peer, and this will be of type backup copy. To check on the peer copy details, scroll down, and in the left you find resources. Under resources, click on disaster recovery. Here you see the disaster recovery section. There is a local peer which is 1 and cross region peer is 0, and it says you can create up to 1 local and 1 cross region peer database. The peer autonomous database is same as your primary autonomous database. The role is of backup copy. The region is same as your primary autonomous database, and the DR type is backup based. This is what I meant. By default, it will create a DR of type backup based, and the peer role would be backup copy. If you want, you can update the DR type to autonomous data guard. For that, you can click on the 3 dots and then click on update DR type. This will bring up a new panel where it says update disaster recovery type. So under this, you find there are 2 disaster recovery types which is shown. One is autonomous data guard and backup based disaster recovery. This is which is already present for the local peer. And other option which you can update with the autonomous data guard. Usually for production databases, you will keep autonomous data guard as the disaster recovery type. But for non-production databases, you can choose backup based disaster recovery. So you have to update the disaster recovery type, you click on autonomous data guard, and then click on submit. Since this is a demo environment, I'll let the local peer be a backup based disaster recovery. Click on cancel here. Just like autonomous data guard, you can also switch over a primary database to its local peer, which is of backup based PR type. So for that, either you can click on the 3 dots and then select switch over, or you can scroll up and click on the link switch over. When you click on the switch over link, it will initiate the switch over operation, wherein it will instantiate the database from the backup, which is stored locally in this region, and then it will assign it the primary role, whereas the existing primary database will take over as standby role. Let's click on switch over. Now under select peer database type, it shows local backup copy. Since we have just the local backup copy, this is what it will only list. So here it shows only the local backup copy, which is currently available as the DR copy for your primary database. So you can put the database name as ATP demo and click on confirm switch over to peer. So once you do that, you'll see there is a state change which shows role change in progress. And if you scroll up, you'll see the status of the primary database changes to updating. Let's give it a few minutes for it to complete. The switchover process has completed. You can check the status of the autonomous database is available, and its role is primary. It is in the same region where you provisioned your autonomous database. You can scroll down to check the disaster recovery menu options, and here you see your autonomous database is having the same name as your primary autonomous database, and the peer role is backup copy, and DR type is backup based, and the state is standby. The region is same US East-1. This is we provisioned a primary database. Since this is a switchover operation to the local peer, you don't have to change any configuration in your application. The same database connection string will work, and you don't need to download the wallet again to reconfigure your connection. You can check the connection to the database after switchover operation. This you can either do from the SQL developer tool, or you can use database actions and connect to the SQL developer web. Click on database actions. This will open up a new tab with all the tools which are integrated with the autonomous database. Log in with the username which you have used during the provisioning of autonomous database. Here we use admin user. So this will open up the launchpad of database actions. Click on SQL. So this will open up the SQL developer web. These are some messages. You can close the window. Now you can run your database queries on the different tables in your autonomous database schema. There is a default schema named SSP which is provided in every autonomous database. You can just take the count of the number of records in line order table. Click on the run button. So this is just output of the query. So now coming back to the autonomous database details page. So we have completed the switch over to the local peer. Now let's switch it over back to the original primary. So for that, click on switch over. And for the peer database, let it be local backup copy, US East region, and then provide the database name and click confirm switch over to peer. This will again take some time to complete. There will be change in the role status like role change in progress, and the status of the autonomous database is updating. Let's give it some time for it to complete. Now our switchover operation is completed, and we have switched back to the original primary. You can scroll down to check the disaster recovery status there. You can also create a remote peer of a backup-based DR type. Usually that is preferred if it is a non-production environment. Suppose the database is a production environment, then in that case, you should create a remote peer of autonomous data type. For that, click on Add Peer Database. So first thing what you have to select is a region. You have to select a region which is paired with the region in which your primary autonomous database is created. In our case, it is US East Ashburn region. Under region, click on select region. These are, click on select a region. These are the list of regions which are paired with Ashburn. Let's choose US East Phoenix, and you can choose a compartment of your own. And for disaster recovery type, we'll choose autonomous data guard. Here you see some information regarding cross region autonomous data guard standby database. Click on RPA database. So here it creates a peer autonomous database with the name ATP demo underscore remote, and the state is provisioning. So right now, a remote peer standby autonomous database is being created using autonomous data guard. If you scroll down, you'll also see the local peer. Check the column DR type. Here you can see the local peer has a DR type value as backup based, and for the remote peer, the DR type is autonomous data guard. And the peer role changes accordingly. Like in case of ATP demo local peer, it is backup copy, whereas for the remote peer, it is standby. Scroll up to see the status of the primary autonomous database. And here the status has changed to updating. This will take some time to create the remote standby for your autonomous database. Let's check back after some time. So back to the console, we can see the status of our autonomous database is available, which means the remote standby database for our autonomous database has been created by autonomous data guard. Scroll down to the disaster recovery menu option, and now under peer autonomous database, you can see the remote standby database, that is ATP demo underscore remote, has a peer role standby, and the state is available. And you can see the DR type is autonomous data guard, which is created in Phoenix region. Just like you did a switchover from the primary to the local peer, you can also do a switchover from the primary to the remote peer database. Note that the switchover operation from the primary to the remote peer is always initiated from the remote peer database rather than from the database details page of the primary database. If you try to perform the switchover operation from the database details page of the primary database, you'll receive an error. Let's try to do a switchover operation from the primary and see what kind of message you receive. For that, click on the three dots and then click on switchover. You will get a message saying cross-region switchover from the primary database is not supported. Perform the switchover operation on the peer database, that is ATP demo underscore remote, which is your remote standby database. You can close the screen. To get into the database details page of the remote peer, you can click on the name of this peer database, ATP demo underscore remote. This will open another window of the OCI console displaying the details of the remote standby database. So this is the details page of the remote standby database. Let's cross check some of the values. You can see here the ATP demo underscore remote, which has a role type as standby. Now going back to the primary database window and check the role against the database, that is ATP demo, which has a role primary. Going back to the window of the remote standby database, so here the role is standby. Now in order to perform the switchover, scroll down to the general information tab, and under disaster recovery you can click on switchover. You can also update the DR type, like currently it is autonomous data type. You can update it to a backup based DR type. In order to perform the switchover, click on the switchover link. This will open up a pop-up. Here you have to fill the database name, that is of the primary database, and then click on confirm switchover to peer. In the interest of time, I'm trying to cancel this operation, but you can try this operation in your tenancy when you're trying to do some hands-on activity. Like you see in the details page of the primary autonomous database, you can also see the disaster recovery details in the remote peer database as well. Scroll down to resource section, and under that, if you click on disaster recovery, here you can see the name of the primary database. The peer role is primary, and what is the region for the primary database. Once you perform a switchover to the remote standby from the primary, and once the remote standby takes the primary role, you'll have to download the wallet and use it for configuring for your applications, as the connection string will change as the remote peer is hosted in a different host in a different region. Apart from that, the URL of the database tools, all that you see under database action will change. So you need to use the new URL which is specific to the new primary database. So this is what I wanted to show you in the demo on disaster recovery features. We saw the different disaster recovery configurations like backup based or the autonomous data guard, and depending upon the environment of your database, like it could be production or non-production, you can choose to configure either autonomous data guard or backup based DR. You can play around with this feature in your tenancy by provisioning an autonomous database and then configuring both types of disaster recovery methods, performing a switch over to the local peer or to the remote peer, establishing the connection, and then switching it back to the original primary. I hope this was helpful to you. Thank you. Welcome everyone. In this video, we'll learn about some integrated tools with the autonomous database. Those that are available as part of your autonomous database service. Grouped under the name database actions, these are a group of self-service tools that are pre-configured in each of your autonomous database deployment. They save a big chunk of your time that you would have otherwise spent for doing the necessary configuration in order to connect with autonomous database. They include development tools, database-specific tools, administration and monitoring tools. They can serve the various class of end users like the developers, data analysts, data architects, or data administrators. These are web-based tools using Oracle REST data services. Here you can see the entire group of available tools that you can directly connect to. These are available in database action space, which you can navigate from your autonomous database details space. You can use SQL Developer Web to connect and run your database queries or develop packages or procedures. You can use data tools like data pump or data load for data loading activity. Use catalog to harvest objects metadata, find the objects lineage. You can use data modeler to create new application data models, generate DDLs, and you can export those diagrams. The data insight tool can generate insights on a table, check patterns, and identify anomalies in the data. The data analysis tool helps you to create analytical views on your data. Likewise, there are tools to monitor, to manage users, to manage JSON collection, REST to develop RESTful services, and quick application development tools like Apex. Access is granted at schema level, hence you must enable schema using ords_admin.enable schema procedure. Admin user has access to all the tools. The connection to the database is stateless. That is, each HTTP request is mapped to a new database session, which means the session terminates after executing the SQL statement or the script. Since the session state is lost, the session attributes do not persist. For example, when executing a DML, if it succeeds, then an implicit commit takes place. Hence, you can use PL/SQL block to send all the session attributes to the database in one session. The monitoring page is only available for autonomous database dedicated and only if you are logged in as admin user. There's a monitoring overview page where you see the use storage, users, sessions, and weights. And there are other pages like Performance Hub page where you can see the ASS analytics, the SQL monitoring, likewise there are alerts page which can show you the alert log messages, the session page to show the currently open sessions, the storage page will show you the use storage and you can further drill down, and there is also the parameters page where you see the initialization parameters. You can explore more on each of these views individually by logging into your autonomous database environment in OCI. So here you see how the database actions page provides you a list of useful tools that can instantly get you started working in autonomous database. There is no need of installing multiple tools on your system or doing any configuration. This is just one stop page where you can get all the required tools pre-configured with your autonomous database. Hope this was helpful. Thanks for watching. Welcome everyone. In this video, we'll check some of the security features of database cloud services in Oracle Cloud Infrastructure. In case of a VM-based database cloud service, the data is by default encrypted using encryption key that Oracle maintains. But you can choose to encrypt the data using your own custom managed key. This is possible due to database services integration with Oracle Vault Service in Oracle Cloud Infrastructure. The encryption keys are administered at CDB level in your database system. This requires your database to be at version 19.13 or later. The key is stored and managed using OCI Vault Service. It is securely stored in PIPS 142 level 3 certified hardware security module in an isolated partition. You must rotate your keys at regular intervals to maintain security compliance. And you must perform the rotation operation from database details page rather than using the Vault Service console page. In an existing database system, you can migrate from Oracle managed keys to customer managed keys. The keys use AES 256-bit encryption algorithms. To enable data guard on DB system databases that uses customer managed keys, the primary and the standby database must be in the same region. You can enable FIPS security enhancements on your DB system, and this will enable FIPS security enhanced Linux and stick standards. This is supported in VM and bare metal based database systems. Below are the steps to enable them using CLI, and if you have an access system, then you must execute this in each node of the cluster. OCI now provides a security hardening tool for your VM-based database systems. This is referred to as stick tool. This is primarily supported for virtual machine systems running on Oracle Linux 7 or later. This keeps you compliant with Oracle Linux 7 stick. This specifically includes a Python script that completes a series of steps to perform security hardening of your VMDB systems. This script is already available in the newer VMDB systems. Otherwise, you can download from OTN or during your DB system agent update, you can also get this particular script. On executing the script, it first creates a base image of your Oracle Linux 7 compliant with the Oracle Linux 7 stick requirement. Then it embeds stick rules that can be activated after provisioning. It categorizes the rules into static rules that are present in the base image and rules that can be activated after provisioning to be compliant with the US Department of Defense or at runtime whenever it is needed. You can view the compliance check as to how many rules are passed. You have the option to even roll back. Your database service is now integrated with Oracle Cloud Infrastructure Security Zone. To briefly explain security zones, a security zone is a cloud construct that is associated with one or more compartment that enforces Oracle Managed Maximum Security SCP, which are a group of policies that provides the highest level of protection for resources that are provisioned in those compartments. When you create or update resource in a security zone, then that operation is validated against the recipe. And if that operation is found to violate any of the policies, then that operation is denied. Security zone compartment is supported with a VM, bare metal, Exadata database cloud service, autonomous database shared with a private endpoint, and autonomous database dedicated. Here are a few examples of enabled restrictions when you provision database in a security zone compartment. Your database must not have a public endpoint, that is, it should not be created in a public subnet. Your database must be enabled with automatic backup. You cannot have data guard association if the primary and secondary are not in the same security zone. You can add other security controls for your database deployment, like you can host your